Hello friends, so today in this video we will go through a question which was asked in GATE 1990. So this question is based on electric field and the effect of this electric field to mobility and the drift velocity. So the question which was asked was, under high electric field in a semiconductor with increasing electric field, and the options were A, the mobility of charge carrier decreases, B, the mobility of charge carrier increases, C, the velocity of charge carrier saturates, and D, the velocity of charge carrier increases. So to understand the answer of this question, we need to know some basic about mobility and how it is related to the drift velocity and the electric field. So here we know that the mobility, let me write it down over here. So we know that the mobility, right, is equal to what? Drift velocity over electric field. So let me consider it as equation number 1. So from this equation we can say that the mobility is inversely proportional to electric field E, right? So the mobility is inversely proportional to electric field E. So that means if the electricity is increasing, so the mobility will what? Mobility will decrease, right? So in this question we have been asked that under high electric field, right? So the electric field is increasing, so the mobility will what? Mobility will decrease. So this is one conclusion that we got from this equation number 1. Okay, so from this equation 1 we can also conclude that the drift velocity Vt is mobility into electric field E, right? So let me consider it as equation number 2. So similarly as equation 1, we'll see the relationship between electric field and the drift velocity. So from here you could see that the drift velocity Vd is directly proportional to electric field E, right? So from this thing what we can see as is, as the electric field increases, right, the drift velocity will also increase. But actually in reality this is not the case. At some extent, when we increase the electric field, the drift velocity is also increases, but after some time it gets saturates. Okay, so let me take another page to explain this. So let me just draw a graph of electric field E and the drift velocity Vt, right? So let me choose another color. Okay, so this one. Okay. So when we see the relation or the graph between drift velocity, change in drift velocity over electric field for the silicon, so it would come something like this. So this is for the silicon, this is for the silicon. For the germanium it is slightly more like this, and for the compound material, that is gallium arsenide, you will see the relationship between drift velocity and electric field, which will come something like this. Okay, so yeah, so here you can see that, okay, so this is the point till which it is increasing, say, linearly, and after that it gets saturated. So we also concluded that as electric field increases at certain point, the drift velocity also increases linearly, right? It is increasing linearly, but at a point when reach, say, when it reach this point, and after that it gets saturated. So we concluded second point, which is as we increase the electric field, the drift velocity saturates. So the answer for this question would be A, right? So the mobility of charge carrier decreases. So here you can see that when increasing the electric field, the mobility of charge carrier is what? Decreases. And answer C, the velocity of charge carrier saturates. So here we can see that the velocity of charge carrier increase, it get saturated, right? It gets saturated here, it gets saturated. It is the point where, this is the point where it is saturate. This is the point where it gets saturated. So the answer would be A and C.